What integer is equal to? We have 1 plus 4 plus 27, and that totals 32. What is the smallest prime number that is greater than 50? Well, greater than 50. So we have the numbers are going to be 51, 52, 53, 54, and so on, right? So let's see. Is 51 a prime number? I don't think so. It's divisible by 17. 52 is divisible by 2. 53, I think, is the one that would answer this question. The smallest prime number, greater than 50. For each positive integer n, the expression 1 plus 2 plus 3 up until n represents the sum of all the integers from 1 to n inclusive. What integer is equal to? Well, at first I thought you'd have to use that formula, n times n plus 1 over 2 for that. But then I realized that, look, all of these cancel when you subtract them all the way up until 2020. All the way up until 2019, because that 2019 would match this guy. So the only things that are left when everything cancels is that 2020 and that 2021. Everything else subtracts itself out. And that is equal to 40, 41. Tam created the mosaic shown using a regular hexagon, squares, and equilateral triangles. If the side length of the hexagon is 20, what is the outside perimeter of the mosaic? Side length is 20, so that's 20. That guy right there. And since they're squares, all the sides are the same, so that's 20. And then that side is also 20 since it's a square, and since those are equilateral triangles, that side is 20. So pretty much all the sides are 20 of the entire shape. So how many sides are there? There are, I believe, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. And each of them is 20. So 12 times 20 would be the answer, and that, of course, is 240. The three scales shown below are balanced. The mass of star is 1 kg. Which of the other objects has a mass of 1 kg? So let's see here. How do I do this? Well, let's just convert these to letters. So this would be 2c is equal to t for triangle and then 1 for the star, c for circle. This one would be 3c is equal to 2t. And this one would be obviously t plus c is equal to 5 square. So I'll just put the square symbol. So now we have to solve this. So from this guy, we get that t is equal to 2c minus 1. And then if I plug that over here, I'll get 3c is equal to 2 times 2c minus 1. And that means 3c is equal to 4c minus 2. So that means 2 is equal to c. Okay. And then if I plug that back into there, I will get 3 times 2 is equal to 2t is equal to, so t is equal to 3. And what are we trying to figure out? Which of the other objects has a mass of 1? Oh, okay. Well, so far, the circle has a mass of 2 and the triangle has a mass of 3. So if the triangle has a mass of 3 and the circle has a mass of 2, I'll plug that into there, and that means that 5 is equal to 5 square. So that square is equal to 1. So there we go. The square is the one that has a mass of 1. So that would be the answer. The diagram shows the first 4 levels of a school's emergency telephone tree. In the case of an emergency, the principal calls 2 students. The first level consists of just the principal, and in the second level, 2 students are contacted. In the next level, each of these 2 students contacts 2 students who have not been contacted. So after the third level, a total of 6 students have been contacted. This continues so that each student contacts 2 students who have not yet been contacted. After the 8th level, how many students are in total been contacted? Okay, so I think this is just let's just put it in level 5, 6, 7, 8. Okay, So this is 2, this is 4, this is 8. So level 5, 16, level 6, 32, 64, and 128. And I think that's all there is to it. And they just want me to add this all up. Yeah, and just the students, right? Because this is the principal, so I don't have to include that guy. So if you add up all these guys, I believe that sum is 254. A group of N students doing an art project use red, blue, and yellow paint. Every student used at least one color, and some students used more than one color. Yellow paint 46, red paint 69, blue paint 104, 14 used both yellow and blue, 13 both yellow and red, 19 both blue and red, 16 used all three. What is the value of N? So we have to use what is known as a Venn diagram, and these are pretty cool. And a lot of you know what these are, a lot of you don't, so let me draw one and let's explain. So this is a Venn diagram. We've got 1 circle, 2 circles, and 3 circles. And in our case, we're going to label them red for that guy, blue, and yellow. So that basically means that that circle represents everybody in the red, and that circle blue, and that circle yellow. Okay, so I'm going to have to put in some letters here, so I'm just going to put in, I don't know the values, so I'll just put in A, B, C, D, E, F, and G. Okay, so now we will interpret these guys. So let's see here. A total, the yellow paint was used by a total of 46 students. So that means everybody in that yellow circle would be 46. So that's A plus C plus D plus G. And that's 46. So that's the interpretation of that point. The next one, red paint was 69. So red is 69. So that is basically A plus B plus C plus E, and that's 69. And the next one, blue paint, is 104. So that's everything in the blue circle. Well, they're all blue, but you understand what I mean. Well, then maybe I can make this a red circle to kind of differentiate a little bit. But I think you guys understand what I mean. The circle that I had denoted as B. So that one is going to be 104. So that's what? A plus B plus D plus F. And that is 104. Okay, now the next one, the 14. That 14 is saying exactly 14 students used both yellow and red, but did not, used yellow and blue, but did not use red. Yellow and blue, but did not use red. So I think that's just D. So D is 14. 13 used yellow and red, but not blue. So that's C. And then 19 used blue and red, so that's B. So that's basically the interpretation of those sentences in relation to the Venn diagram. Okay, so now we got to solve for, what is N again? N is, what's N? Oh, N is the total, all the students, so that would be the whole thing. So N is A plus B plus C plus D plus E plus F plus G, the whole thing. So some of these we already know. So when we're figuring out N, let's see here. A we don't know yet. B we know is 19. C we know is 13. And D we know is 14. So all I really need to do is figure out E, F, and G. Yeah, E, F, and G. Well, that shouldn't be a problem because from this first guy here, let me use a different color. From this first guy up here, that one, I can figure out the value of G because I have, hold on a second. I need A, right? Oh, I forgot this one. I forgot this one. That's why I was confused. 16 students use all colors, so that means A is 16. Ah, okay, I got it. That's what I was wondering. I said, where's A? Okay, so I just need to figure out E, which is this one, F, and G. Okay, that shouldn't be a problem. Okay, so going back to what I was trying to talk about, from that one, I can probably figure out G since I know the value for A, C, and D. This is A, this is C, and this is D. So that's pretty straightforward math, and when you do that, you'll get G equal to 3. So put that in here. And then from this guy, I'll be able to figure out the value for E, since I know A, B, and C. And when you do that math, you get E equal to 21. So that goes here, and then from this guy, I'll be able to figure out F. And F is 55. So that goes there. And there you go. That's pretty much all what N would be. And when you add up all those numbers, you'll get 141. So 141 students is the answer. A real number x satisfies the equation 1 over x plus x over 80 is equal to 7 over 30. What are the possible values for x? A real number. So let's do this math here. We've got 1 over x, x over 80, and 7 over 30. So let's get a common denominator. 80, 80, x, and x. So that'll be 80 plus x squared is equal to 80x. Right? And that's 7 over 30. So cross multiply, and you'll get 560x is equal to 2400 plus 30x squared. And then I think I can divide through by a 30 here. And that'll give me x squared minus 56 over 3x plus 80. Oh, I gotta do a messy quadratic here. Oh boy. Well, that shouldn't be so bad. X is equal to 56 over 3 plus or minus the square root of b squared. 56 over 3 squared minus 4ac. So 80 all over 2. So I'll let you guys do that. It basically is 56 over 3 plus or minus 5 1/3, which is 16 over 3, I believe. And don't forget that over 2. So when you do this, you actually get two numbers. You get 12 and you get 20 over 3. And those are the two real numbers that satisfy that equation. Nabil has a tablet that starts with its battery fully charged to 100%. The battery life decreases at a constant rate as the tablet is used. He uses the tablet for exactly 60 minutes, after which 68% of the battery life remains. For how many more minutes can Nabil use the tablet before the battery is at 0? Starts off at 100%, right? And you're going down to 68%. And that happens over the span of 60 minutes. And then they're saying, how much longer will it take for it to go to 0? So let's call that x. So this is a simple question with like, how you say, comparison. So to go from 100 to 68, we basically went down by 32%. So, right? And that took 60 minutes. So we want to go now from 68 to 0, so we want to go another to 68%, and we want to know how many minutes is that. So that's basically the comparison, and that would be 32x is 60 times 68, and therefore x, when you do this math, is 127.5, and I believe that's minutes. In the spinner shown, all circles have the same center. Inner ring is divided into equal sections, numbers 1 and 2, numbered. The middle ring is divided into equal sections, numbered 1, 2, 3. The outer ring is divided into equal sections, numbered 1, 2, 3, and 4. After the arrow is spun, it lies on one section of each of the 3 rings, and the score is the total of the 3 numbers in these sections. For example, in the spinner shown, the score is 2 plus 2 plus 3. which is 7. The arrow is spun once. What is the probability the score is odd? So let's take that diagram that they have given us, and we'll divide it into these sections, 12 sections in total. And you basically just draw lines that cut through the circles. And then for each section, we create the sum. So for example, if I were to look at, say, this section right here, it's 1 in that inner circle. And then in the middle circle, it would be 1. And in the outer circle, it's 1. So that's why the sum was 3. We can do this sum another way. Like, let's say this guy here, this section. The inner circle, 2. The middle circle is 3. And the outer circle is 4. So 2 plus 3 plus 4 is 9. That's why they got 9. So they're saying, what is the probability that the score is odd? Well, okay, well, it's odd. I'll circle all the odds, the sums, that is, and 10 of those 12 sections, this sum will be odd. So, and that basically, of course, in lowest terms is 5 over 6. In the trapezoid ABCD, AD is parallel to BC. Also, AB is equal to CD. BC is 9. AD is 21, and perimeter ABCD is 50. What is the length of diagonal AC? So let's cut this down the middle here at right angles like that. And let's see what we can do here. So BC is 9, and then therefore this would be 9. And then AD is what, 21? So that means if you subtract from 21, 9, we will get 12. So that means this would be 6 right here. And then this would be 6 also. And then, did they give us anything else? Oh, the perimeter is 50. So I'll just call this side X. I'll just call this side X because of the fact that BC is parallel, so those two will be the same. So that means that 2x plus 9 plus 21 is 50. And therefore, X would be 10. And what do they want me to figure out? AC. Okay, so AC is the diagonal. Like that, and that's right angle. So I think I'm going to have to first figure out the height, and then I'll be able to. So the height, we'll just call it h, top to bottom. 6 squared plus h squared will be x squared. And then 6 squared plus h squared is 10 squared. So that means h is equal to 8 when you solve for that. So then I can use triangle, well, this red triangle that I created, that this side is 15. So 15 squared plus the height squared, which is 8, which I just calculated, is AC squared. Right? So 64 plus 225, and then take the square root, and I believe that's going to be 17 for AC. A parabola passes through the point of intersection of the lines y is equal to minus x plus 3 and x minus 2i minus 6 is 0, as well as the x-intercept of each line. If the parabola also passes through the point 10k, what is the value of k? Okay, so let's do this here. First, we would have to set them equal to each other. So what am I doing here? Minus x plus 3 is y, and x minus 2y minus 6 is 0. So that means if I set everything equal to y, you can do it either way. This would be x is equal to 3 minus y, and x is equal to 6 plus 2y. So that means 3 minus y is equal to 6 plus 2y. Therefore, 3y is equal to minus 3, y is equal to negative 1. And then when you sub it back into there, you'll get x equal to 4. So 4, negative 1 is basically the intersection point. And so if I were to attempt to draw this, we've got this here, x and y, 4, negative 1, so 1, 2, 3, 4, negative 1, let's say here. So do we know anything here? What are the other ones? x-intercept of each line. Okay, that will definitely help. X-intercept of the first line is set when y equals 0, so that means x equals 3. X-intercept of that line set y equal to 0, and therefore x would be 6. Oh, okay, that's pretty helpful. So 3, and then here. So it's going to look something like this. Something like that. Okay, so what are we trying to figure out? Oh, the parabola also passes through 10k. What is the value of k? Oh, so I've got to figure out the equation of the parabola. Okay. So this is going to take, well, hopefully not too much time. We have y is equal to ax squared plus bx plus c, right? That's the sort of the standard equation of a parabola. And we substitute these points in. So that point is 4 minus 1. This point basically is 3, 0. And this point is 6, 0. So when I sub in those points, I will get the following equations. I'll get 9a plus 3b plus c, and call that equation 1. I'll get 36a plus 6b plus c, that's equation 2. And equation 3 will be 16a plus 4b plus c. And you have to solve these system of equations, and I'll let you guys do that because I'm sure you can do it, right? I mean, pretty straightforward stuff. So when you do, you get a equal to a half, b is equal to negative 9 over 2, and c equal to 9. So that means the equation of the parabola is y is equal to 1/2 x squared minus 9 over 2x plus 9. And then you substitute that 10k that they wanted us to put in. Where is it? Up here. That point 10k. So 10k you substitute in there. So 10 for the value of x and k for the value of y. So k would be 1/2 10 squared minus 9 over 2 times 10 plus 9. And when you crunch out these numbers, you'll get k equal to 14. And Bill and Carol each have some tokens. There are 4 exchanges of tokens that happen in the order below. First, Ann gives Bill the number of tokens that Bill has, and so on. After these 4 exchanges, they all have 36 tokens each. How many tokens did Ann have before the exchanges? Okay, so we've got to make a little table and talk about this carefully. Okay, so Ann, Bill, and Carol I will label as A, B, and C. Okay, so let's talk about this now. So we have the first Anne gives Bill the number of tokens that she has. Okay, but before the first, let's actually label them. Let's give them some sort of starting values. I'll just call it X, Y, and Z. So they start off with those amounts. And then the first exchange, we will have to interpret these. So this will become 2y, and this will be x minus y, and this remains z. That's the interpretation of that sentence. That Anne gives Bill the number of tokens that Bill has. And then next, I guess, the next one is this one. That interpretation in terms of mathematics would be, and keep in mind that number twice, that they kind of sneaky, that they put that in there. You might completely miss that. So this actually would become 3z. This is 2y still. And this is x minus y minus 2z. Okay, so far so good. And then next, this guy, that interpretation, this remains 3z. And then this will be 2y minus x minus y minus 2z. Yeah, and then this, of course, would be 2 times x minus y minus 2z. And then finally, again, don't miss that twice in there. Bill give Carol twice the number of tokens that Carol has. So that means this is going to go up to 9z because he's giving 6. And then therefore this will be 2y minus that x minus y minus 2z minus 6z. And this remains the same, 2x minus y minus 2z. Okay, and at this point, all of these guys are 36, according to what they tell me. Okay, so now, and what are we trying to figure out? We're trying to figure out how many tokens Anne had. So basically, we're trying to figure out the value for x. Okay, so from this, 9z is 36, so that means z is 4. So we got that. That's pretty good. And then we're going to have to sub that into these two equations. So the first one is 2x minus 2y minus 4z, and that's 36. So that basically means that 2x minus 2y, since z is 4, minus 8 is 36, or sorry, minus 16 I should say, since it's 4. So that means 2x minus 2y is equal to 52, and then when we divide through by 2, we get x minus y is equal to 26. So we do the same kind of thing on this guy here. So that will be 2y minus x plus y plus 2z minus 6z is 36. So 2y minus x plus y plus 8 minus 24 is 36. So well, this is going to be 3y minus x is equal to 52, I believe. So if I just add these guys, I'm going to get 4. Let me think about this. No, 2y. 2y will be equal to 78, and therefore y is 39, and therefore x, when you sub it back in, will be 65, and that is what they wanted. GOA is drawing triangles using 3 of the points in the box below as vertices. Below are 3 triangles that GOA might draw. And the first 2 of these, if the first 2 of these are considered to be different, how many triangles of positive area can GOA draw in that way? We have 7 dots here, and to choose 3, it would be 7 choose 3, right? So that's 35. So you say, okay, well, I can make 35 triangles. But that's not true, because a triangle will not be formed if the dots are in the same line. So if dots, the 3 dots that you choose, if dots are in the same line, like for example, the dots in the top row, these guys, if I chose that, it would just be a straight line. That does not form a triangle. So what we have to do is subtract from that 35, subtract from 35 the scenarios in which the 3 dots are in the same line. So the first scenario is this top row right here. So that's the first scenario. So that's 1. And then from the bottom, you can also choose 3 that would be in the same line. There's four of those dots, and from those 4 dots you want to choose 3 in order to get 3 on the same line, and that's 4. So from this guy you will get 4 additional scenarios in which you form a straight line rather than a triangle. So 4 plus 1 is 5, so those 5 are the scenarios that you have to subtract from that 35, and when you do, you get 30, and 30 is the answer to the question. How many positive integers x with x between 200 and 600 inclusive have exactly 1 digit that is a prime number? So we've got 3-digit numbers, and we want exactly 1 digit to be prime. So basically only 1 digit to be prime. Okay, so well, first of all, the digits that are prime are 2, 3, 5, and 7, right? And the digits that are not prime are 0, 1, 4, 6, 8, and 9. 1 is not a prime number. Okay, so let's talk about this. I think we have to break this up into segments. So first that segment, then the next segment from 300 to 399, then the next segment, and the last segment, which is 500 to 599, and then the 600, that itself 600, neither 6 nor 0 is prime, so that doesn't qualify. Okay, so for this one, we'll have a 3-digit number that starts with a 2. Now 2 is a prime, so I'll put P for prime. So that means these two have to be one of these, the non-primes. So we've got 6 choices there and 6 choices there. So 6 times 6, 36. So we have 36 numbers in that range that would fit the criteria of the question. Okay, now this guy, all those numbers are 3 something something. Now that's already prime also, I believe. So that same kind of thing, we would have to put a non-prime there and a non-prime there, 6 choices there, 6 choices there, multiply those together, and we get 36 choices. For that one, this one's a little different because 4 is what goes there for those numbers, but 4 is not a prime. So either we have this a prime, or we have the last guy a prime, because only one can be a prime. If the second one is a prime, we've got to choose from that group, and there's 4. And then for this guy, it has to be a non-prime, so 6. So 4 times 6 is 24. And then same kind of thing here. If that is a prime, we've got 4 choices there, and we have 6 choices here, so 24. So 24 plus 24. So this is 48 for that range. And for the final one, that's going to be a 5, so this has to be a non-prime, because 5 is a prime, so we got 6 choices there, 6 choices there, so 36. So in total, this 36, that 36, that 48, and that 36. And I believe when you add those up, it'll be 156. Suppose f is a function that satisfies f at 2 is 20 and f at 2n plus n times f at 2 is equal to f at 2n plus 2 for all positive integers. And what is the value of f at 10? Okay, so we got to do a bunch of stuff here. So let's see here. F at 2n plus n f at 2 is equal to f at 2n plus 2. So let's start with n equals 1. And I think we're going to have to do n equals 2, n equals 3, and so on, right? Okay, so if n equals 1, this will become f at 2 plus 1 times f at 2. But f at 2 is 20, so let me just put that in there. And this will be f at 4, I believe. Now f at 2 is 20, so it'll be 20 plus 20 is f at 4. So f at 4 is equal to 40. But we want f at 10, so obviously we got to keep going here. So n equals 2. When n equals 2, again, sub it into that formula, we'll get f at 4 plus 2 times f at 2, but I'll just plug that in as 20 since that's the value. And then this will be f at 6, right? So f at 4, we already got 40. This is 40, and this is f at 6. So f at 6 is equal to 80. Now let's do n equals 3. n equals 3, then that would be f at 6 plus 2, or sorry, 3, I should say. F at 2, which is 20, is equal to f at 8. So f at 6 is 80. So 80 plus 60 is f at 8. So f at 8 will be 140. And then finally, this one I think will give us the magic answer. So that'll be f at 8 plus 4 times 20 is equal to f at 10. And therefore f at 8 is 140. And then that's 80 is f at 10. So therefore f at 10 is 220. Suppose a, b, and c are real numbers, a less than b less than 0 less than c, f at x be a quadratic function, g at x be a cubic function. Both f at x and g at x have the same y-intercept of -8, and g at x passes through the point -a8. Determine the value of c. Determine the value of c. All right. So where do I even begin with this question? I'm trying to think here. Well, f at x is equal to x minus a times x minus c, right? That they give us that. And they also give us something. They give us something else. Oh yeah, they gave me this point that's on both, so I can use that. So that means f at 0 is -8. So -8 is basically equal to -a times negative c. So negative 8 is equal to AC. Okay, that's a pretty good start, I think. Now let's go back to the cubic function, which is g at x. Let's do that over here. So g at x, that is x minus a times x minus b times x minus c. And let's stop with the same point. So when g at 0 would be negative 8. So that means negative 8 would be minus a times minus b times minus c. So minus 8 is minus ABC. Is that right? Yeah, I think so. And then this guy I can substitute. So let me just break that up here. So AC times negative b. So minus 8 times minus 8 times minus b. I think therefore b would be negative 1. Correct? Okay, that's pretty good. Okay, where do I go from here now? So I think now we got to use that point. And that point is only on the cubic function. Yeah, it's only on g at x. Okay. So therefore, g at minus a is 8. So therefore, 8 is equal to, what was g at x? Oh, this guy. That one up there. Okay. So I'm using minus a, right? So minus a minus a, minus a minus b, and then minus a minus c. Okay. All right, so this is 8 is equal to minus 2a times minus a, but b is negative 1, so that's going to be plus 1 there. And then c, we got, oh no, we only have AC. We don't have the individual values. Okay. Not a problem. We'll try to figure this out. So this is what we have. Okay, so what do I do here? Let me just get rid of that 2, so that'd be minus a, like that. And then this, if I expand this out, it'll be a squared plus, let me think about this. AC minus a minus c. Yeah. Okay, so that's when we can use that. So AC is minus 8. So this is a squared minus 8 minus a minus c. Yeah. And then finally we expand this now, so we get minus a to the power 3 minus plus 8a plus a squared plus ac. And then I got it. So AC is minus 8. So I can finally get rid of the C's, and I'll just have a whole bunch of A's, and hopefully that will help me. So AC is minus 8, right? Okay, so great. So now let's put everything on one side, and when you do, you get a to the power 3 minus 8a. Well, hold on, let me arrange it properly. A minus a squared minus 8a plus 12. Oh, we got to factor this. I think well, it's got to be a divisor of 12, so I'm going to try 2, and then that would make me get a squared plus a minus 6, and then this will be easy to factor. A 5 1 no 6 1 I think 6 1 or 3 2 I think. Yeah, 3 2. And then positive, negative. Yeah. So therefore, A. Well, we got A is either equal to 2 or negative 3. But A, I think A is less than 0 from that original question stem. So that means A's got to be negative 3. And then finally, we go back to this guy, which stated that negative 8 is AC. And then we have A is equal to negative 3. So therefore, C would be 8 over 3. 8 over 3 is the value for C. AC and BD are two perpendicular chords in a circle. The chords intersect at E as shown with BE equal to 3 and EC equal to 2 and AE equal to 6. The exact perimeter of the quadrilateral ABCD may be written in the form M root n plus P root q, where M P and Q are positive integers, and Q is greater than N, and neither Q nor N has a divisor that is a perfect square greater than 1. Determine the value of root Mn plus root P plus Q. Okay, well, let's draw a few lines here, and let's see here. Okay, let's label this as best as we can. BE is 3, AC is 2, and AE is 6, okay? If I had ED, that would be very helpful. And I think I could, because the chords are perpendicular, right? So let me, the diagram is going to get really messy, so let me just draw it. Let me just draw these guys like that. So the chords are perpendicular, so those are perpendicular, and this is A, and this is B, this is C, and this is D, right? And let's see here, what? Okay. This is a very interesting question here. A lot of people might have even missed this. This angle is going to be the same as that angle, and I'll tell you why. Because they subtend by the same arc. Or the better way, or another way, not necessarily better, but another way is that they both emanate or originate from AD. So if you go from A and D, you can create this angle here, that theta. And then again, if you originate from A and D, you can create that angle. And since they originate from the same 2 points, or they subtend by the same arc, they're equal. Yeah. Okay, so that actually means that those two are similar triangles. So that means that the triangle ABE is similar to triangle DEC. Okay, that's very helpful because that will allow me to get the value for ED. So BE over EC using the similar triangles is AE over ED, and therefore 3 over 2 will be equal to 6 over ED, and therefore ED will be equal to 4. So I'll substitute that in there, right there. So now what we can do is we can just use Pythagoras to figure out all the other ones. And I'm sure that you guys can do that on your own since we know the values, right? We have 3 here, this is 2, this is 6, and this is 4. So I'll just do 1. So BC squared would be 3 squared plus 2 squared, and therefore that's BC is root 13. So that guy there is root 13. And very similarly, you can figure out that CD is root 20. The AD is root 52. And that AB is root 45. So the perimeter, when you add it all up, will be root 13 plus root 20 plus root 52 plus root 45. And when you break that up into mixed radicals, it'll be 3 root 13 plus 5 root 5. Now, keep in mind that Q is greater than N. So since Q is greater than N, that basically means that the Q is the 13 and the N is the 5, and therefore the P would be the 3 and the M would be the 5. So finally, what they want up here, which is the root of M times N plus the root of P plus Q, that would be 5 times 5 root plus 13 plus 3 root. So that's 5 plus 4, and that is equal to 9. So 9 is the answer to this question. The table shown is to be filled with the integers so that the integers in each row form an arithmetic sequence that increases from left to right. The integers in each column form a geometric sequence that increases from top to bottom, and the 3 geometric sequences have the same common ratio, which is an integer. Determine the sum of all possible values of b. Well, let's fill this in first the best we can, and then we'll take it from there. So this will be 5 plus d, 5 plus 2d, since it's an arithmetic sequence. The next one, this will be b minus d, like a different d, and this will be b minus 2d. And then this one will be 900 minus d, we'll call it d2, and this will be 900 minus 2 times d2. Okay, not very helpful at that point, but that's when we go to the next piece of information, is that top to bottom is geometric. So basically what that means is that if we, for example, let's look at this one first, this guy, this column. It basically means that b over 5 plus 2d is the same as 900 over b. That's basically how you'd figure out the ratio, right? So b squared would be equal to 900 times 5 plus 2d. And yeah, that's pretty much how you do it. Now, the same kind of story is true for this guy and this guy. So it would be b minus d over 5 plus little d is the same as 900 minus d2 over b minus d, like that. So b, oops, sorry, that's a big D, right? Yeah. So b minus big D all squared is equal to 5 plus d times 900 minus d2. And the same kind of story will hold true for that column. But let's work with this guy here, because there's way too many variables here. Let's see what we get. Okay, so from this guy, what I noticed is that b squared is equal to 900. But 900 is already a square. So that basically means that the only way that this can be a perfect square, this is a perfect square, so the other side has to be a perfect square also. The only way that's possible is if this is a perfect square. So 5 plus 2d has to be some perfect square. So I'll just call it m squared. And that will allow me, I believe, to figure out values of d and then eventually values of b. Yeah. And then I'll just have to add up all the values of b. Okay, so let's make a table and see what happens here. And then let's just keep those guys in the frame if I can. So I've got m squared. I've got 5 plus 2d. Then I have d. Then I have the value for b. And then 900 over b is the ratio, right? And the ratio has to be an integer. And that's very helpful, actually. Yeah, that right here, the ratio has to be an integer. Okay, that's yeah, the ratio has to be an integer. And another thing that's helpful is this statement that it's increasing from top to bottom. Yeah, so that means the ratio, since it's increasing, the ratio has to be greater than 1. Yeah, otherwise it wouldn't be increasing. So ratio has to be greater than 1, and ratio has to be an integer. Okay, I'm pretty sure that's the interpretation. Okay, so let's go with this and let's see what happens. So I don't know how long I'm gonna have to do this for, but hopefully not too long. Okay. So let's anticipate at least about 5 to 10. Okay, so m squared. If m was 1, this would be 1 squared. So that's 1, and then we can easily sub it back into here to get the value for d. But these actually don't give values of d because d would be negative, and we have to have, again, it increasing, so d has to be greater than, d has to be a positive number. So that's no good. If you have 2 squared, which is 4, d again doesn't give, but when it's 3 squared, which is 9, that's the first time you get a value for d. And then for b, how would you figure out b? It's this equation right here. So let me put that in the frame. So you'd put b over 5 plus 2d is equal to 900 over b, right? Which is essentially the same as this. I mean, it's the same equation, it's just rearranged a little bit. And when you do that, you get a value of 90. And now let's check this guy. The ratio would therefore be 10. And is it greater than 1? Yes. And is it an integer? Yes. So this value of b is legitimate. It fits all the criteria of the question. So let's just keep going like this. So this is 16. We won't get an integer value. We'll get a positive value, but we won't get an integer. We need integers. Wait, is there anything that says that? Yeah, because they have to be integers. That's the only way you can get an integer. Okay. I gotta just make sure that I don't mess this up. Okay, so next one is 25 for m squared. When m squared is 25, we'll get d equal to 10. And then we will get 150. And then let's do this check. This is a 6, so that's valid. So that makes that b legitimate. Okay, so let's keep going here. 6 squared will not give you an integer, but 7 squared will. That's 49. And that will be 22. And this, therefore, would be 210. Remember, we're using those equations. But we still have to make sure that the ratio is an integer, and it's not. So this value of b, we can't count. And you just kind of keep going like that. So I'll just fill it out. 64 would give me nothing, not an integer. But 81, I think, would give me 38. And then this is 270, but unfortunately, this is not an integer, 3.3. 121 would be 58. And then this would be 330. 2.7, no good. 13 squared, 169. That would give me 82. And for b, it would be 390. But then this would be 2.3, no good. 15 squared, 225 would give me 110, which would give me 110 would give me 450, and this would give me 2. So that is good. So that's legit. And then everything else would give me an integer would give me a value that's not an integer. Or, yeah, it would give me a value that's not an integer because I've run out of integers because the ratio has to be greater than 1. So the smallest integer is 2. So this is the smallest I can get for the ratio. So the only values of b that satisfied all the conditions were the 90, the 150, and the 450. And when you add all those up, you get 690 because they wanted the sum. Suppose that f at x is 2x plus 1 over x minus 2, and y is equal to g at x is a linear function. F at negative 1 at g at 2 is 7, and g at negative 1 at f at 1 is 4 over 5. What is the value of the x-intercept of y is equal to g at x? Okay. Well, there's a shortcut, which is you do f at 1 like that, and it cancels each other. But I'm gonna do the long way just because I want you to understand all this. And then once you understand it, then I'm sure you can do the shortcut. But if I do the shortcut immediately, some of you may not understand what's going on. So let me just do it the long way. So first we start off with this 2x plus 1 over x minus 2, right? And in order to get the inverse function, we have to reverse the x and the y's. So if I reverse the x and the y's, this becomes x, this becomes 2y plus 1, and y minus 2. So, and then I rearrange this in order to get it in terms of y, and I get 1 plus 2x after I do all the algebra. So this is my f at negative 1 at x. Got it? So that's basically what you would do. So let's take a look at this now. They have given me that f at negative 1 at g at 2 is equal to 7 up here. So what does that mean? And they've also given me that g at negative 1 at f at 1 is equal to 4 over 5. Okay, so let's see what we can do here. Do we have an equation for g at x? Yeah, y is equal to g at x. But what's the equation here? Oh, we're not given an equation. We're just told that it's linear. Okay, so g at x is some linear function, and all linear functions are of the form ax plus b. And therefore y is equal to ax plus b. And they want the x-intercept. So if you get the x-intercept, you set y equal to 0. So 0 is equal to ax plus b. And therefore minus b over a would be x. So that's basically what we're looking for. Let me just put that in red. So I'm assuming that we have to figure out the numerical values of b and a. And that's how we're going to figure out what is that. Okay, so that takes care of that. I'm just trying to make sure that this is done properly. Okay, so now where do we go from here? So g at 2, this guy in here, that is going to be, if we use that equation, 2a plus b. And then if we put that into this f at negative 1, that would be 2a plus b, and that's 7. But remember, we got to use this guy for f at negative 1. So that's going to be 1 plus 2 times 2a plus b all over 2a plus b minus 2, and that's 7. So if I've done this properly, I think so, and then I cross multiply and collect like terms, I'll get 0 is equal to 2a plus b minus 3, and therefore minus b would be 2a minus 3. Okay. I think that's pretty decent progress. And then now we've got to turn our attention to this guy now. So g at negative 1, first we got to figure out what g at negative 1 is. Yeah. Well, first, let's see here. G at negative 1, f at 1. Well, f at 1, this is f at x. So f at 1 would be 2 times 1 plus 1 over 1 minus 2, right? And that is equal to 4 over 5. So g at negative 1, and that's 3 over, so that's negative 3 basically, is equal to 4 over 5. Then we got to get the inverse function. Okay, inverse function. Now the inverse function from this guy, if that's y is equal to ax plus b, then you flip it, so there'd be y is equal to ay plus b. X is equal to ay, so x minus b over a would be y. So that would be the inverse function, g at negative 1. So you put negative 3, it would be minus 3 minus b over a is equal to 4 over 5. Minus 3 minus b over a, yeah. So then if you put this into, if you cross multiply, you get 4a is equal to minus 15 minus 5b. And therefore, 4a plus 15 over 5 would be minus b. Okay, So I've got minus b equal to this, minus b equal to that, so I set it equal to each other. So 2a minus 3 would be equal to 4a plus 15 over 3. And when you solve for this, which I'm sure you can do, you get a equal to 5, and therefore sub it back to get b equals 7. And then finally, for that guy, minus b would therefore be 7, and then a is 5, and therefore x is 7 over 5. That is the intercept that they're looking for. If n is a positive integer, the symbol n exclamation, read n factorial, represents the product of the integers from 1 to n. For example, 4 factorial is 1 times 2 times 3 times 4, or 4 factorial is equal to 24. Determine. All right, so you got this whole thing, right? And then we're going to use some log rules. So the first log rule is this one, that the log of b to the base a is equal to 1 over the log of a to the base b. So if I apply that to all of those, each of those then becomes log of 2 to the base 100 factorial, plus the log of 3 to the base 100 factorial, plus the log of 4 to the base 100 factorial, and so on, all the way to the log of 99 to the base 100 factorial, plus the log of 100 to the base 100 factorial. Okay. Then we use another log rule, and that one is the one that states that if you have the log of two numbers, x times y to the base a, it's the equivalent of the log of x to the base a plus the log of y to the base a. So if we apply that to this guy, since all the bases are now the same, so for example, they're all like a, we can combine them all. So it would be log of the same base, but it would be 2 times 3 times 4, 99 times 100. And then therefore, this guy, this is just 100 factorial. And then you guys know that this log rule, that the log of a to the base a is equal to 1. So this is equal to 1. How many integers n is this expression equal to an integer? We will first see what we can do with the factoring, and then we're going to have to use a little bit of what is known as fancy algebra. But not too fancy though. So not too fancy algebra. So let's explain what we will do first with factoring. So the top one, that factors to n minus 1, and then 2n squared minus 10n minus 12. You have to experiment with divisors of 12, and when you do the long division, this works out. And the top one, a little bit challenging, but the bottom one is really straightforward. That's just n plus 6 and n minus 1, I believe. Okay, so that n minus 1's cancel. So all you're left with is 2n squared minus 10n minus 12 all over n plus 6. Okay. So now this is what we do with the fancy algebra. So we want to break this up. So what we'll do is we'll put 2n squared, and that minus 10n, we break it up into plus 12n minus 22n, and then this minus 12 we'll leave alone for now. So 2n, that allows me to factor this into n plus 6. That's over n plus 6. And then this minus 22n plus 12 over n plus 6, like that. So that's helpful because that now allows me to cancel out that n plus 6. And that's the whole purpose of that fancy algebra. Okay, well, we're still going to do that again with this guy. So let's do that again in a way that allows us to again factor it. So 22n, let's see here, plus 132 minus 120, and I think that'll allow me to do it. So 2n So this will be a factor out of 22 n plus 6. There we go. Over n plus 6. And then that'll just be, I believe, a plus 120 over n plus 6. So then this is 22n minus 22 plus 120 over n plus 6. So at this point, this is what allows us to kind of look at this and say, what values of n will this become an integer? Okay. Well, this is always going to be an integer. Whatever n is, 2n will be an integer. This is already an integer. That's just minus 22. So this part we don't need to worry about. We just have to look at that. For what values of n is 120 over n plus 6 an integer? Well, 120 divided by n plus 6 will be an integer when n plus 6 is a divisor of 120. And 120 has, unfortunately, a lot of divisors. There's one plus or minus 120, because I don't think it says anything about positive or negative, right? Just integer. So it could be negative. Plus or minus 120, plus or minus 60, plus or minus 40. There's a lot, actually. But there's 32 of them, 32 divisors. And for each of those divisors, you'll get one value of n. All lead to n equal to an integer. So, for example, if you set 120 over n plus 6 equal to 120, that would mean that n plus 6 is equal to 1. So n is equal to minus 5. Is that right? Minus 5 plus 6 is 1. Yeah. And then it could be positive or negative. I was just unsure about that. So all of these will be integers. So therefore, you'll have 32 integers n that will make the expression, that original expression up here, this whole thing, that will make the expression original an integer. An angle theta with theta between 0 and 180 satisfies root 2 cos theta. 2 theta is cos theta plus sine theta. Determine all possible values of theta. All right. Well, we're going to use some trig identities here. Like that. So, let's see here. And then we are given this. So I guess root 2 cos 2 theta is equal to cos theta plus sine theta. And then this is this. So let me put that in. So root 2 times cos squared theta minus sine squared theta is equal to this cos theta plus sine theta, right? I believe so. Okay, so let's factor this guy. So that's going to be, let's see here, what is that going to be? Cos theta, sine theta, and then plus or minus, right? Okay. And then if I were to rearrange this, bring everything over to one side, I think I can factor out that cos theta plus sine theta. And then when I do, I will get root 2 cos theta minus sine theta, and then I think I will get a negative 1, I believe, and that's going to be all equal to 0. Okay, so that basically means that either cos theta plus sine theta is equal to 0, or it means that cos theta minus sine theta is equal to 1 over root 2, I believe. Let me just see if I did that properly. Yeah. Okay, so let's take this one step at a time. And then, of course, let's not forget our parameters between 0 and 180. So theta is between 0 and 180. Okay, so the first one, that one, let's see. If I put sine theta is equal to minus cos theta, so sine theta over cos theta is negative 1. So that means tan theta is negative 1. So in this range, tan theta would be -1 if theta is 135. Okay, so that takes care of that guy. Yeah. Okay, so now we turn our attention to this. So what do I do here? I think I'm going to square both sides. If I square both sides, I'll get cos squared theta minus 2 sine theta cos theta plus sine squared theta, and then that'll be a half, right? And this plus that is 1. That's a very famous trig identity, so that will make that 1. And then therefore this will be a half is 2 sine theta cos theta, and this itself is a trig identity. It's the sine of 2 theta. Okay, that's pretty good actually. So now I'm going to draw a little graph here. So theta, what was my parameter again? It was between 0 and 180. 0 and 180. But I'm talking about 2 theta now, so 2 theta would be between 0 and 360. Yeah, so that's why I'm extending it to 360, and that's 180 there. So we want a half, so it'll be basically that and that. It'll be 2 values. And are you allowed to use calculators on these exams? I think so. On the Canadian exams, they normally let you. On the U.S. exams, they don't. But in any case, a lot of you who have knowledge will be able to figure that out. Knowledge of trigonometry will be able to figure out, even without a calculator, that those values are going to be 30 degrees and 150 for 2 theta. So that means that theta is either 15 or 75. But this question is a little tricky because you got to verify these, because when theta is 75, this falls apart. This cos theta minus sine theta actually gives me minus 1 over root 2. And remember, it was supposed to give positive. Yeah, so you have to go back and double check. But fortunately, the 15 works out. So the only values that actually work when you go back and verify are this one and this one. So theta is either 15 or 135 only. "20 buckets, each with a volume of 6 liters, are stacked in a pyramid as shown, with 10 buckets in the bottom layer, 6 in the second layer, 3 in the third layer, and 1 in the top layer. Each layer is arranged in an equilateral triangle, and the buckets are stacked so that each bucket, other than those in the bottom layer, rests on exactly 3 buckets in the layer below. Water is poured into the top bucket 1 liter at a time. After a liter is poured, the water is allowed to settle. Before another liter is poured, if water is poured into the bucket that is full, that water spills over the rim of the bucket in such a way that exactly 1/3 of the runoff goes into each of the 3 buckets on which it rests. For example, once the top bucket is full, additional water spills equally into the 3 buckets in the second highest layer. At first instant, when at least 1 bucket on the top layer is full, what is the total amount of water that has been poured onto the top bucket? Okay, so I'm assuming you understand the question. So let's go with this. So we have layers, right? So we have the first layer, second layer, third layer, and fourth layer. So the first layer, it will fill with 6 liters of water. And then once that is filled and you continue to pour more water, it'll spill over into the second layer. And the second layer will be completely filled when we have 18 liters of water, right? Because there's 3 buckets on the second layer and each will hold 6. So far, once we have completely filled the first 2, we have poured 24 liters of water. Okay, so that's very important. Okay, so now we move into this third layer. Third layer, of course, is a little bit more complicated of a conversation, so I'll try to explain it. I'll draw a bird's eye view of the third layer. So third layer is going to have six buckets, right? So this is sort of a bird's eye view. Okay. Now, these buckets, we've got 3 of them that are what I'm going to call corners, and 3 of them that I'm going to call edges. So E for edges and C for corners. Now, the corner ones are going to receive water from only one bucket. And you will see that. So the corners receive water from only one bucket. Okay? But the edges, those edge buckets that I label as E, they receive water from 2 buckets from above. From 2 buckets from above. Okay? So if we were to pour 9 liters of water now, they would be distributed as follows. You'd get 1 liter into here in each of the corner buckets, but 2 would go into each of the edges, right? Because the corners are receiving water from only 1 bucket from above, but the edges are receiving water from 2 buckets from above. So that naturally the edges would get twice as much water as the corner ones. I hope that makes sense. Now, these edges will be completely full when they have 6 liters of water. So if 9 resulted in this, in order to get 6, you'd have to put in 27. And let me just move this a little bit to the, and let's draw this again. Not drawing the scale, of course. When you put 27, these will become 6s. And then these will be 3s. So now I have poured in 27 liters of water. Okay? So let me just circle that 27. So after this 24 and this 27, I have the following scenario. Row 1, or it was called layer 1, right? Yeah, sorry. Let me just call it layer 1. Avoid confusion. Layer 1, which is this guy, is full. That had 6 liters. Layer 2, which is this guy, is also full. But layer 3 is in this scenario. And with that scenario can be described as follows, that the edges are full, the edge buckets are full, but the corner buckets, those are half full. They only have 3 liters. Got it? And we have poured in that much. So 24 plus 27, which is what, 51? We've poured in 51 liters so far. Okay, so hopefully so far you're following. So far it's not too complicated. And then fortunately, this question, I think we only have to go one more step. Now we have to first get all these corner buckets to be full, and only after that happens will the final layer start receiving water. So we have to put in another, to get these 3s into 6s, 3, 3, and 3s, we have to put in another 9 liters, right? Yeah, we have to put in another 9. So another 9. So another 9 here. And when that happens, these guys will then be all 6s. 6, 6, like that. Okay. Now at that point, that gets all 3 layers full. So layer 1, 2, and 3 are now all full. Full, full, and full. Okay. Now, any water that's being poured on the top will start to arrive in that bottom layer, which is called layer 4. Now, let's draw layer 4 here. Layer 4 has 10 buckets, right? So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So now we have to figure out, if I pour water, how does it get distributed? You might have to look at that diagram again. Yeah. How does it get distributed? Well, when we were pouring water from we're pouring water onto the top, right? So after this, so let's just backtrack a little bit. After this happened, layer 1 was full, layer 2 was full, and layer 3, the edges were full for layer 3, and the corners were half full. It's this scenario right here. That was after the 24 and the 27. But then we continued to pour water. But we want to start having water go into the bottom layer. So let's pour 27. So instead of looking at it 9 at a time, let's look at 27, see what happens. If we pour 27, these threes, right, these threes went up to 6s, correct? So that's 3, 3, and 3. So 9 of that 27, which is basically what I wrote there, is what makes that third layer full. But the remaining 18, that is what flows into layer 4. So that is, I think, a better way of explaining it. So that 18 spills into that bottom layer. And those bottom layers, I'll have to start labeling now. Just as before that, those are the corners. These are the edges. And unlike before, we've got a center one. I'll call that. So we got a corner. We've got edges. And we have a center, one center bucket. And this is probably the most challenging part about this question. So the corner, when this is happening, we're concentrating on this. When the 18 liters starts flowing, the corners actually do not receive any. They receive 0. Why? Because when we're pouring water into that scenario, these corners those corners are being filled. But when the water is going into the edges, since those edges are already 6s, that water is actually going to be flowing to level 4. So the edges, if you notice, they're here. Let me just draw it on the diagram. That's an edge. And that water will only go into this guy and this guy. Only edges will have water flowing into level 4. So the corners will not receive any water during that kind of scenario. The edges of the bottom row will receive water from one bucket from above, as I showed here. So one bucket. And the center will receive water from 3 buckets. So you can probably see that in the diagram. Actually, yeah, you probably could if you look at it closely. So therefore, if you look at this distribution, the distribution will be as follows. It'll be a distribution of 3, 1, 1, 1, 1 for all the edges, and then 0. So if we have 18 to distribute, let me draw this again. 18, so that would mean 1, 2, 3, 4, 5, 6, 7, 8, 9. So we got to double those. So that'll be 6, and these will all be 2s, and these will be 0 still. And therefore, the center is full. And that is what they wanted. They wanted at least one bucket in the bottom layer to be full. And then they're saying, how much water do you add in total? Okay, well, let's count that. In total, so far, we have added this 24, that 27, and this 27, of which 9 went into layer 3, and the 18 flowed into layer 4. So 24 plus 27 plus 27, that is 78. So 78 is the answer to that question. The point N is the center of the face ABCD of the cube ABCDEFGH, as shown. Also, M is the midpoint of the edge AE. If the area of triangle MNH is 13 root 14, what is the edge of the cube? Well, the triangle as root 14 times 13, and that's M and H. Let's label this. Let's call this 2x. Since M is the midpoint, that'll be x, and that'll be x, the distances. And therefore, we're going to have to figure out some, using Pythagoras, m squared will be mh squared. This is going to be in triangle MEH. So mh squared would be x squared plus 2x squared, correct? Yeah. So that's going to be 5x squared, so therefore mh is root 5x. Okay, so that's pretty good. So let's see here. We're going to figure out some diagonals. BD squared, that would be AD squared plus AB squared, like that. So BD squared would be 2x squared plus 2x squared. So that's 8x squared, right? Yeah. So therefore BD would be 2 root 2x. 2 root 2x. So then, very similarly, AC, if you were to do that diagonal, that's also 2 root 2x. So if you were taking the midpoint, which is DN, or DN or BN, whatever, those midpoints, DN or AN or however you want to do it, those are going to be half of that. So it would be root 2x, like that. So then in triangle NAM, let's draw that in, NAM, in that triangle, MN squared would be equal to AN squared plus AM squared. So that's going to be root 2x all squared plus x squared, and therefore 2x squared plus x squared. So that'd be 3x squared. So MN would be root 3x. Okay. So we've got MN, we've got MH, I just need NH. Okay, NH, the other side. So that triangle would be triangle DNH, I believe, in that triangle. So that means NH in that triangle would be equal to DN squared plus DH squared. So DN squared is same right there, root 2x all squared. DH is the full top to bottom, so that's 2x squared. So that's going to be 2x squared plus 4x squared. So that's 6x squared. So NH is equal to root 6x. Okay, so we've got all three sides of that triangle. And I initially thought about herons, because you've got basically a scenario. We've got a triangle M and H, and MH is root 5x, NH is root 6x, and MN is root 3x. And we know that the area is 13 root 14. But unfortunately, herons becomes complicated because you have roots. Roots complicates things. If there were just numbers, we could do it very quickly. So herons wasn't really a good option. So then I guess we have to use trigonometry. Yeah, you're going to have to use trigonometry. So for example, if that's theta, then the area, you guys remember, right? How to figure out the area with trigonometry. It would be 1/2, in this case, mn times nh sine theta. Yeah. Okay. And, well, 13 root 14. One mn is root 3x. nh is root 6x. And then, we don't have sine theta. Okay, so I got to figure out what sine theta is. And once I have sine theta, hopefully if I have a numerical value, then I can figure out the value for x, which is, I think, what they want. No, they want the side length. And the side length is 2x. So, but first, of course, I'd have to figure out x. Okay, so let's concentrate on trying to figure out sine theta. And I think I'm going to have to use the cosine law on this triangle. On triangle MNH, right? So using cosine law, that would be mh squared is equal to mn squared plus nh squared minus 2mn times nh times cos theta. And when you sub in these guys, it becomes 5x squared is equal to 3x squared plus 6x squared minus 2 times root 3x times root 6x times cos theta. And then collect like terms, and you will get, let's see here, 2 root 18 x squared cos theta is 4x squared. The x squared's canceled, so you get root 18, which is 3 root 2 cos theta is equal to 2. So cos theta would be equal to 2 over 3 root 2. And then rationalize the denominator, and we'll get 2 root 2 over 3 times 2, so root 2 over 3. But that's cos theta. We want sine theta, so I can put it in there. Well, I can just use that trig identity. Cos squared theta plus sine squared theta is 1. So this would be 2 over 9 plus sine squared theta is 1. So sine squared theta is 7 over 9. So sine theta is root 7 over 3. Okay, finally. So, take this guy. 13 root 14 is equal to 1/2 root 18 x squared. And then sine theta was, what was it again? Root 7 over 3. Root 7 over 3. Okay, so 13 root 14 is equal to 1/2. That's 3 root 2. 3 root 2. Root 7 x squared. And then over 3. So let's see here. Root 14 times 13. The 3's cancel. That becomes root 14 when you multiply root 2 by root 7. Okay, so the root 14's canceled. Then 26 is x squared. So x is root 26. And then finally the side length is 2x. So 2x is equal to 2 root 26. Oh, there we go. That is the answer to the final question.